You are watching DHTV from California State University, Dominguez Hills.
All right, good morning and welcome to the Los Angeles County Economic Development Corporation's Future Forum, The Future of Aerospace, 5G and the New Age Space Race. A special showcase presented by California State University, Dominguez Hills. My name is Shane Cullen and I oversee events for the LADC and will be your Zoom tech and moderator for today. We have a star-studded program of presenters and panelists who will be sharing their insights with you. But before we start, as always, let me explain how you can talk to us during the webinar. If you are having technical difficulties during this webinar, please utilize the chat feature to send those concerns directly to myself or my colleague, Ricardo Ruffalo. This can be found in the controls at the bottom of your screen. We will be answering questions during the Q&A portion of today's program. To submit questions for the panel, please use the Q&A feature also in the controls at the bottom of your screen. Again, if you'd like to submit a question for the panelists, please utilize the Q&A feature, not the chat feature, to submit those. We will send you all the relevant links by early next week, including a link to the webinar recording. And don't forget, join the conversation online by utilizing the hashtag LAEDC Future Forum. Now, without further ado, I'd like to introduce the CEO of the Los Angeles County Economic Development Corporation, Bill Allen.
Thank you, Shane, and good morning, everyone. Welcome to day 3 of our reopened California economy. My name is Bill Allen. I have the privilege of serving as President and CEO of the Los Angeles County Economic Development Corporation, better known as the LADC to most of you. And for those of you who don't know us, our mission is to reinvent our regional economy to collaboratively advance growth and prosperity for everyone in our region. We do so through direct services, through published research, and policy advocacy. And we are your hosts today for this Future Forum. If you're anything like me and my colleagues at the LADC, you are really looking forward to spending more time looking forward, especially after a year like no other and one that we hope is increasingly in our rearview mirror. So it's fitting that we gather for the latest in our series of LADC Future Forums, today on the future of aerospace, 5G and the new age space race. Innovation in aerospace has a long and remarkable history here in LA County, and the pace of that innovation is rapidly accelerating here and will continue to do so well into the future. So it's important that we occasionally reflect on the nature of change in such a foundational industry to our regional economy and what that portends for the ecosystem here and the needs for talent to power that innovation well into the future. And that is why I'm particularly grateful to our longtime partner, California State University, Dominguez Hills, for their foresight in bringing these conversations to the public and for serving as our Future Forum series presenting sponsor, really presenting partner as we see it, since we began the program more than 5 years ago. California State University, Dominguez Hills is a diverse, welcoming community of learners and educators, collaborating to change lives and communities for the better. With strong academic programs, dedicated faculty mentors, supportive staff, and many campus amenities, CSU Dominguez Hills is a powerful engine of social mobility, connecting students to a high quality and transformative education while providing our communities with a vital resource for diverse talent, knowledge, skills, and leadership needed to thrive today and tomorrow. And this morning, we're also joined for this particular Future Forum by our partners at Bank of America, who are the featured sponsor of this aerospace discussion, a topic of great interest to their team. Later on, I'll introduce Michelle Iturralde, one of their senior vice presidents, who will be moderating today's panel. But first, it's my pleasure to introduce a remarkable force for good in our region, a highly valued member of our board at the LADC, a transformative leader in higher education, and the 11th president of Cal State University, Dominguez Hills, my good friend, Dr. Thomas Parham. Dr. Parham, welcome.
Thank you, Bill. And I'm glad in your introduction, there's a claim to you and I being friends. That is one of the best things I do, my friend. And I thank you for all your leadership in the LAEDC.
Thank you.
So good morning, everyone. I'm honored to again serve as one of your sponsors, to host the LAEDC's Future Forum. Today's forum, ironically, marks the final event in this year's series and the 5th time it will have been held in virtual format. So even as we're all looking forward to getting back into a face-to-face engagement with a level of authenticity and genuineness that just comes from being able to engage people, we will celebrate, I think, the adaptations to the adjustments we've had to make even in this virtual space. I want to thank the LAEDC for sponsoring these informative forums and for bringing together, I think, such an impactful group of panelists today. And each of the previous forums, I think that your California State University, Dominguez Hills has had an opportunity to participate in. And I'm proud that CSUDH continues to be a presenting sponsor for in highlighting the challenges and opportunities facing the South Bay industries and the South Los Angeles region. These forums provide a welcome and necessary glimpse into the future we will all be sharing. Now, the focus of today's forum, of course, is on the aerospace industry, and in particular, an aspect in that is near and dear to me personally, which is using emerging technology to help close the digital divide. Now, the aerospace industry has long been one of the engines driving Southern California's economy, but recent years has been an uptick in investment, I think, in research, and really interest throughout the entire region. And as much as time as I spent on airplanes, like lots of you, I'm excited to hear what our guest panelists have to say today. So whether creating the capability for commercial space flight or devising new methods of exploring Mars or other planetary neighbors, this aerospace industry is a hotbed of innovation that is once again, I think, thriving in our region. The leaders who are joining us today are uniquely positioned to speak on how our local aerospace industry is working to bridge one of the most pernicious and lingering side effects of our rapid transition to virtual workspaces and classrooms. And throughout the past year, particularly the ones that we've been on lockdown, access to reliable telecommunications and internet services have become even more vital for those wishing to participate in global society. And yet there remains that big digital divide between those with easy access to a variety with few, if any, methods of connecting remotely. Certainly we've had that challenge exposed in our space. So today we'll hear from industry leaders to speak on how they are working to bridge this divide, designing and launching scores of new satellites into orbit with the goal of providing truly equitable access to the wonders of modern telecommunications technology and in working through aerospace. And so we'll also hear what economic impact that these leaders are having, and particularly for the aerospace industry, as it continues to impact what we do in Southern California, and how it will be one of the leading factors helping to lead this area in its post-COVID economic recovery. So let me close by saying that your California State University, Dominguez Hills, has long teamed with area leaders working to mold our curriculum and match the needs of local industry. Our new master's program in systems engineering is just one of those innovative programs that we've developed in tandem with local industry, creating a cohort of graduates who will be ready and able to step right into positions in a range of disciplines. So our university, your university, is dedicated to the success of our students and this community. And by working with forward-thinking, innovative businesses like these represented here today, we'll be able to continue to position our graduates for success and provide local industry with talent and creativity that needs to grow and thrive. So thank you once again to the LAEDC and my friend Bill Allen for hosting this event. And I'll now turn it back over to Bill as I thank you on behalf of all of the 17,763 students at Dominguez Hills, our illustrious faculty, our dedicated staff, and our senior leadership. We're proud to be a partner with you, my friend.
Thank you, my friend, for those great remarks, for your tremendous leadership and all our years of partnership in this really fascinating series of Future Forum conversations. And I know you join me, and I think all of our audience, in being excited about hearing from our speakers. It's my pleasure to introduce you all to our keynote speaker, Renard Turpin, who's the Chief Engineer of Boeing Commercial Satellite Systems and Common Products. Mr. Turpin also leads advanced satellite architecture development and technology insertion as the Chief Technology Officer for Commercial Satellite Business Development. In 2018, Renard was recognized as Boeing Defense, Space, and Security Engineer of the Year, and we are really delighted to have him with us this morning. Renard, welcome. The platform is yours. We look forward to hearing what you have to share with us.
That video definitely makes me excited to be part of Team Boeing Space. Good afternoon, everyone. I'm Renard Turpin, and I'm happy to be here today to talk about the emergence of new technology, how it's enabling a 5G future, and how Boeing in Southern California is supporting this future while positively impacting LA County's economic footprint. So now our Boeing Space team does a lot of things that are literally just out of this world. Starting with the building of the next generation satellites right here in El Segundo, to growing solar cells and arrays in Silmar, to providing support for NASA's Space Launch System. That's the rocket that's going to take the US back to the moon and onto Mars. The International Space Station, over 2 decades of humans operating in space. And CST-100 Starliner, augmenting our nation's capability to access the International Space Station. Our entire space portfolio touches Southern California in some way. At Boeing, we like to say that our diverse portfolio of programs stretches from sea to space. So before we talk about the technology that's enabling 5G, let's first define what it is and what it means. 5G is the 5th generation mobile network that will exponentially have more capability than previous generations. 5G will transform the way businesses, individuals, governments, and even machines connect globally. In support of this 5G future, Boeing is building the next generation of satellite technology to enable 5G services such as the cloud and the Internet of Things. Now, we can all look around and see our homes are becoming more and more connected, whether it be through our home security systems, smart appliances, or energy-saving bulbs and sockets. In today's smart home, you can even ask Alexa to brew your morning coffee, or even wake you up to your favorite wake-up song. According to a recent study, consumers will also spend over $123 billion on the Internet of Things technology by 2022. And this number is expected to grow. The conveniences of a connected smart home come with increased demand for data and speed. Now, this is where satellites are going to play a starring role in the future. 5G connected future will be powered by satellites. Now, right now, Boeing is building 5G capable satellites. In fact, we're building a constellation of them called the O3B mPOWER Network for our customer, SES. If you walk through our satellite factory today here in El Segundo, you'll find satellites ranging from LEO satellites to giant 20+ kilowatt geosynchronous orbit spacecraft. Now, we're building satellites of every size and every orbit. Now, what started as the mission to connect the other 3 billion people of the world without connectivity, that mission has evolved to supporting critical industries. Now, from carriers providing 5G services to connecting cruise ships and airlines to enabling offshore energy operations and remote mining and government communications, this new satellite-powered communications infrastructure will do more than just connect individuals or connect the smart home. It's actually going to enable industries to evolve and meet the demands of the growing digital revolution. It'll even enable artificial intelligence and machine learning. As a matter of fact, we use generative machine learning techniques to automatically design portions of the O3B satellite. Now, Boeing, we call our 5G satellite technology 702X. Its computing power is 20 times greater than its predecessors. The 702X is built smart. It uses all of the latest smart antenna technology to send data to users around the globe. And it's not just about computing power, it's about the way it's manufactured with exponentially fewer components, just like a laptop. Now, less components means we're able to reduce the mass of the satellite by about half. The mass of satellites is important in our industry. The more mass and the more power you need to lift that satellite into space. and mast over lifting power equate to rocket cost. So we designed our satellites to launch 3 or 4 of these technologically advanced satellites on a single rocket. Now, pushing the boundaries of building the next generation technology, that doesn't happen without having a deep talent pool right here in Southern California. And I mentioned that Boeing builds satellites in El Segundo, but we have 13,000 Boeing employees throughout California, not only working in space, but Boeing Global Services, Boeing commercial airplanes, and other parts of our building, of our business. Boeing's footprint in California extends to an extensive 2,500 suppliers, equaling 6.6 billion in purchases by Boeing in the state each year. We're also proud to say that through this investment comes the support of 168,000 direct and indirect jobs. We're also proud to support the community, not just through our work, but through charitable contributions and grants. Our Boeing teammates also love hands-on volunteer work. In previous years, Boeing has donated over $14 million and 45,000 volunteer hours here in Southern California. So in closing, I just want to express to you all again that I am excited about the prospects of 5G and digital transformation with respect to Southern California and the aerospace industry. I'm Renard Turpin, and I'll see you again shortly on the panel. Thank you.
Yeah, my name is Pete Gettle, and I work for aerospace. And today I'm going to talk about satellite systems, which can be used for consumer broadband. So what we're going to cover today are a comparison of some well-known wireless technologies, the FCC's role in trying to promote broadband, especially in rural communities. We'll talk a little bit about consumer terminals, and then we'll go over some constellation features to give you a feel for what it means for satellites to go around the earth and serve a broadband market. Okay, so here are the popular or the typical wireless technologies. We're all familiar with Wi-Fi and cellular, and satellite is a little bit unusual, but Wi-Fi, well, we have a Wi-Fi base station and our devices talk with the Wi-Fi base station. Cellular tower, we've driven around and seen cellular towers on the sides of roads. And the devices that talk with base stations and cellular towers are the cell phone, our smartphones, our tablets, our PCs, and our laptops. And then another wireless technology is satellite. And you notice there's a little bit different thing going on with satellite, and that is, well, we have a satellite, and that satellite connects to the ground via a ground station. But that ground station requires a distribution method that's common and popular, otherwise it would get very expensive. And that's why you would hook up a satellite base or satellite ground terminal to a cellular tower or Wi-Fi base station. So some of the differences among the technologies, that's what we'll talk about now. So Wi-Fi and cellular base stations and towers are fixed. The satellite for the broadband constellations, that will move across the sky. And the range of satellite is much larger than for a tower or base station. In fact, if you were in LA, it's the equivalent of having a tower all the way in Tucson. That's the distance that the signal has to travel. And the amount of area that Wi-Fi and cellular towers serve, much less than satellite. A satellite might serve a region as large as Pennsylvania or even as large as Texas. And power, because satellites have to cover so much more area and the range is a lot longer, the amount of power that a satellite needs to have is larger than cellular and Wi-Fi. And the data rates for all the systems are roughly comparable, and the costs are different. Satellite is going to be more expensive than cellular or Wi-Fi. And then the terminal, that's actually pretty important, because you can't have a communication system, a wireless communication system, without something that can talk to the node or the base station. And for Wi-Fi and cellular systems, it's cheap antennas that are inside your devices. You don't even notice them. But for satellites, since the range is so large and since the satellites move across the sky, we need a tracking antenna. Okay, so the FCC is very interested in promoting broadband in rural areas, And they've started a new program called the Rural Digital Opportunity Fund. And that in that fund, there's about $20 billion of subsidies that can be spent over 10 years. And companies can apply for subsidies, but to do that, they have to meet certain minimum requirements, and those are indicated in the purple box below the map. So the data rates into each household have to be at least 25 megabits per second. And then the data cap has to exceed 250 gigabytes per month. So what you see in the map are a bunch of blue dots, and those are the blue dots. Those are the areas where the FCC is trying to get broadband because the current providers aren't able to provide the speeds that are indicated in the purple box. And on the right, there's a table, and we won't go through the whole table, but these are a list of the top 10 recipients of subsidies in order of the amount of money that they can receive. And if you look, number 4 on the list is SpaceX, and there they plan to use their Starlink constellation, which is a low Earth orbit satellite constellation, to serve many, many areas inside the US, and they've applied for almost $900 million of subsidies. So they don't get the subsidies until somewhere along the way. I don't know if they get all the way into providing service or if there's some kind of milestone system in place. But anyway, SpaceX, Starlink plans on doing this by satellite. And if you look, every other provider on this list is using some kind of fiber or wired technology. So we don't want to go through the entire list of terminal providers here, tracking antenna providers here. The key thing to note is that there's a bunch of people that have been, or a bunch of companies that have been trying to do tracking antennas. And many of them have tried to do them for consumer applications, but they've struggled because it's very difficult to build a tracking antenna that's inexpensive. The last company on the list, Starlink, is the one who seems to have come the closest so far. So Starlink advertises a terminal, and you can go look on their website. And their terminal, the price is $500. And what's in the public domain is that it costs about $1,500 for them to make. And that by far is the least expensive tracking terminal available on the market. Okay, so it helps to see when we're talking about LEO or broadband constellations with LEO satellites, it helps to get a sense of, well, what's going on? You know, how are the satellites going around the Earth? You know, what does it look like? So this is a view that helps us, or an animation that helps us understand that. So depicted here are 2 different orbits. One is a polar orbit, that's the red orbit. And you can see there's a bunch of S and then a number, and I think it goes up to 36. So there's 36 satellites in this particular orbit. And what you notice is these satellites, they go around the Earth as the Earth spins below. And then there's a yellow orbit, and you can see that one doesn't go over the top of the Earth. That one kind of goes, I guess, kind of over the side of the Earth. Anyway, so that's an orbit that's inclined, not inclined as much as the polar orbit, which is the red orbit, but this is also a popular orbit because some constellation providers don't want their satellites to go over the North Pole because there's not a lot of money to be collected up there. So anyway, the whole takeaway from this is that in these constellations, satellites are placed in orbits. They're generally evenly placed in their orbits, and they go around the Earth as the Earth spins below them. Okay, so on this slide, what we have are depictions of a series of orbits that would be in a LEO constellation. So this is not any particular LEO constellation. This is for illustrative purposes. So what you see are red. They're actually arcs, even though they look like lines, and those on the left, and those represent the orbits that go around the Earth. So it almost looks like the Earth is captured inside this big red net. And that red net goes from, well, the orbits go from either the lower left to the upper right. Okay, there's a bunch of orbits that do that. And then a lot of orbits on this slide also go from the upper left to the lower right. So the satellites would travel around in these orbits. And you can see that some of the orbits are indeed over the United States. So the satellites that are in that part of the orbit could serve the US. And the other thing you notice is that there's lots of satellites that will be over the ocean. So that means that service providers have to be really careful with how they design their constellations, because a lot of their infrastructure is over areas where there's not a lot of people. So it's important to understand, how to get business in those areas, and also understand that the amount of infrastructure that you need to serve, let's say, a place like the US, it needs to be amplified by all the regions that satellites need to be, but can't provide service. And then the picture on the right, the depiction on the right shows the top of the Earth. Okay, so what you see in the white there is like the North Pole and the Arctic. So the idea is that the satellites that are in these inclined orbits do not necessarily serve the top of the Earth. They could if they're made into polar orbits. And what a constellation provider will do is decide how much revenue they're going to collect from that part of the Earth, and then weigh that against the cost it takes to provide service in that part of the Earth. So that's just a trade that a service provider will make. Okay, and this is our last slide. So we talked about terminals and the constellation. So what also can help us get a good feel for LEO constellations is the service area for individual satellites. So what we have here are two examples of LEO constellations. So above the purple line, the purple horizontal line, we have an 800 satellite constellation. So in this satellite constellation, we've got 20 orbital planes and 40 satellites per orbital plane. And if you multiply 40 by 20, you get 8 satellites in total. So there'd be 800 satellites going around the Earth. And if you freeze the constellation for an instant in time, what you can find is the number of satellites and which satellites would serve the United States at a particular instance in time, in the United States and its territorial waters. So for this constellation, we'd have about 21 satellites serving the US. So if it turns out the demand in the US can be satisfied by 21 satellites, then this would be a good constellation. So the constellation on the bottom of the purple bar, well, that's a much thicker, much larger constellation. So in that constellation, we've got 60 orbital planes and 120 satellites per plane. So multiply those two numbers and we get 7,200 satellites in total. And then if we freeze that constellation, we can look at the satellites that serve the US. And in this case, it's about 273 satellites over the US and its territorial waters. So a constellation designer, architect, and a company that wants to implement this type of system is going to try to assess the amount of demand in the area they want to serve, and then try to figure out, how many satellites they need to do that. And then they'll come up with the number of orbital planes, the number of satellites per plane to help them reach their goal regarding service. And then for a good business plan, that will be balanced against the amount of revenue that are expected to be collected in the service region of interest. And that wraps up what I wanted to say about LEO broadband systems. And if you have any questions, please email them or send them via chat, and we'll do our best to answer them. Thanks for your time. Thank you.
Thank you very much for that explanation for those of us who know far less than you about these systems. And you and Renard have really set the stage for a fascinating panel discussion this morning. So thank you both very, very much. And thanks for the incredible work the Aerospace Corporation does with so many of our aerospace contractors, with the LA Air Force Base, the Space and Missile Systems Command. It's just a wonderful partnership that exists here in Los Angeles County that is at the center of so much innovation in space commercialization today, as well as aerospace and defense. Before we transition to the expert panel, I just want to remind everyone in our audience, you can join our conversation today on social media by using the hashtag LAEDC Future Forum. We actually invite you to do that so that more folks can know about the exciting things being developed here and discussed here today. So now it's my pleasure to introduce our moderator for our expert panel. Michelle Iturralde is the Senior Vice President, Global Commercial Banking for Bank of America Aerospace and Defense. Michelle is the Senior Vice President for the Middle Market Global Commercial Bank of Bank of America, based here in LA. She's a Senior Relationship Manager leading B of A's aerospace, defense, and government services practices. B of A has banked the aerospace industry for over 75 years. Bank of America is the #1 lender with over $6 billion in loan commitments globally. And Michelle's an experienced industry banker delivering solutions tailored to meet the company's strategic and growth needs. Michelle, we're delighted to have you with us today. Thanks for your partnership in putting today's conversation together. And I'm going to turn the rest of the program over to your capable hands.
Thank you, Bill. I'm very excited to be here today. So being a part of the aerospace industry with Bank of America for so many years, then watching space technology thrive here in Los Angeles has been amazing. So thank you for having me, and being part of this forum is great. So I'll go ahead and introduce a few more panelists and then invite Reynard and Pete to come back into the discussion. So I'll start with Van Escobotti. Van is co-founder and managing partner of Starburst Accelerator, where he unites early stage technology innovators with private investment. He launched Starburst in the US in 2015 and now operates globally alongside more than 400 tech startups. He develops new spacecrafts, satellites, drones, sensors, and autonomy robotics with these startups. Also joining us today is Jeff Matthews. He is a leader at Deloitte Consulting's government and public sector space industry group. Jeff provides expertise on commercial space technology trends and launch systems economics. Jeff advises early stage technology companies and brings a unique perspective to the commercial space market. He's also a space industry contributor to Reuters, Forbes, and NBC News, Discovery News, and more. Also joining us today is Amanda Stiles. Amanda's Director of Mission Management for ABL Space Systems here in Los Angeles. She leads the customer experience from contract to payload deployment. Amanda has over 15 years of experience in launch and space operations, mission management, payload integration, business development, and software experience. She's worked with early stage companies, including Rocket Lab, overseeing launch missions and directed the company's moon program. She also worked on lunar programs with Google and NASA and has experience in mission operations at SpaceX. So I plan to review a list of questions, but also we'll cue the audience for Q&A. I already see a handful of questions, so thanks for submitting those. Let's get started with the panel, and we'll start with the growth and investment opportunity in commercial satellite launch capabilities. Launching of satellites into LEO for GPS and satellite communications, as both Pete and Reynard have reviewed earlier today, is not a new concept. However, the growth in past years with companies like SpaceX and Amazon satellites is unprecedented. Can you comment on what's driving the recent demand and the increased investment from both the private and public markets? So why don't we start with you, Jeff, if you don't mind, maybe kicking us off.
Yeah, sure. No, thank you for having me today. And it's exciting to be here. I've always been a champion of, if you really want to right size the market and unlock some of the exponential value that space and space technologies can bring both to the globe, to the nation, and especially to Southern California, it requires a mixed mode set of architectures. You're not always going to want to launch a very heavy rocket. You're going to want to right size for your mission capabilities at the right time, the right economic price, and with the right sort of service level and scale. I think that has really driven the recognition that there are opportunities for investment in that entire class of launchers, from ultra small to ultra heavy, and also in the supporting infrastructure and capabilities that are required to get them to orbit. So for example, there's been I think a renaissance of small launch companies that are really tracking, towards doing all this, but there's also been renewed efforts in the state of California around Vandenberg Space Force Base, for example, and I've been privileged to help work on that commercialization program, really trying to take advantage of also then how do we serve that launch community and drive that forward as we see additional demand and use cases tick upwards.
Great. Reynard, any comment on that?
Yeah, I'll just tap on to what Jeff mentioned earlier and also in the beginning of the presentation. So the demand, starting off with our just need for more and more data. That's driving the technical solutions to utilize all of space. Traditionally, if you go back when we didn't really utilize much, I would say, information coming into and out of a home or business, we would use larger satellites that required specialized rockets, and they would sit, like I said, 42,000 kilometers above the Earth in a geosynchronous orbit. And that really did not stimulate much of the commercial launch sector. As the data rates have increased and much of that demand has increased over time, we're finding that hybrid architectures, meaning architectures that utilize very small satellites, where you can actually design them for shorter lifetimes. That means you can get an order of magnitude lower in cost, as well as capability. Because they're so close to the Earth, essentially you can beam a lot more information to a user with a lot less energy. You just need more of them. So that second requirement, which means you need more of them if you're going to get closer to Earth, that really spawns the need for smaller, less reliable and more simple, less complex launch vehicles. And you're seeing that diversity show up. You're seeing it basically bring on quite a few new companies into the farm. So the launch costs have dropped dramatically. And as an architect, we love that. We're able to design new systems that bring new capability every day just because of that. So I would say that the primary driver here is data, and the solutions that our architects come up with require those rockets, and that's driving that demand.
Starburst works with the venture capital community, early stage startups, entrepreneurs around the world. When we think about demand, you have to keep in mind the types of non-traditional investors in private capital that's thinking about these opportunities and continuing to exploit that, where the demand signals are coming from. In a very general sense, you have 8 billion people in the world today, 60% of whom are connected to the internet. And when you think about the big tech companies, why is Amazon and others even interested in participating in this domain around increasing that type of connectivity? What does it mean to create opportunities for banking, for ordering food delivery, for socializing, if you can create connectivity for that remaining part of the disconnected world? So there is incredible demand that has potential that we have yet to unlock. In addition to those in developed countries that have that existing connectivity, I've heard statistics around people would rather be delayed than lose connectivity during their travel. So you seriously have to think about the more incredible use cases that are being developed by savvy entrepreneurs and businesses that are sourcing capital from unexpected places, as well as those big tech champions, whether it's Netflix or Facebook or anybody else, that wants to make sure that the disconnected parts of the world that creates huge potential can tap into the same opportunities that the developed world has. So we are just at the beginning, and I think there's gonna be a lot more of that coming.
Yeah, I can appreciate when I'm on a flight and they don't have any Wi-Fi capabilities. It doesn't, the experience is very different. So thanks, man. No, that is pretty incredible. And I'd like to kind of shift to the 5G journey. You know, the 5G network journey for aerospace and telecom is one that there's a convergence of industries. The idea of providing broadband access to all, as you've mentioned, Van, is an opportunity for both telecom and aerospace to tackle together. So what does this convergence mean for aerospace? And how will aerospace companies partner with the telecommunications industry to address the anticipation of this 5G network journey? I mean, Pete, some of the statistics that you gave in your presentation of what the constellations look like today, what they will look like potentially in the future, and then the funds that have been earmarked for companies like SpaceX to make that happen. Would kind of love to hear a little bit more about, you know, your perspective on the network journey and how telecom and aerospace are working together to address it.
Right. So it's funny because it's called satellite communications. It's been called that probably since the 50s. But the telecom companies and the satellite companies have very, very little overlap. And that's historical. If you look at the amount of economic activity in the telecom industry and the satellite industry is I don't know, 1% or maybe a fraction of 1%. So the satellite industry has not, it's just been adjacent to telecom. The skill sets, the engineering, all that, it's just been different. But now with the need to get communications to places that the terrestrial infrastructure is not really, it's too expensive to roll out. You know, if you're putting fiber in the middle of Montana, you got to pay for the run, you got to pay for all the people to do it, all the equipment, and then you got to look at the revenue that you're going to get. And that just goes, I mean, that's a business trade that all the big telecom operators are making. So it just hasn't come down, you know, we need to do it. But now people look at, well, how do we connect those people? And now with the FCC been pushing for more than 10 years to make that happen. Now there is more, I don't know if synergy is the right word, but there's like a commonality now between what a satellite company can do and what a telecom company would be interested in. But still, even with that, you saw that in the top 10 list of subsidy recipients, SpaceX was the only satellite company in there. So I think that I've been to many of these conferences where people talk about telecom and satellite coming together, and it sounds nice when people are up on a stage, but I think that there really has to be that economic tie-in between the two to make it happen. And the push for broadband in remote places and maybe satellite being the way to deliver it, that might be the kick that needs to get these two groups to come together.
Yeah, it's funny, you mentioned the financial benefit of the convergence of both the aerospace and telecommunications industry. Still trying to figure that out. But I think of ESG. ESG is a concept that we've heard about for many years, but I think over the last couple of years, probably more than ever. And I think one of the drivers behind the 5G network journey is really affordability and connectivity. As you mentioned, there are parts of this world, parts of this country who unfortunately don't have the connectivity that maybe a Los Angeles region has. So, a goal is to have the greatest impact in areas leveraging 5G where it's limited or even non-existent. Where is the investment for new technologies coming from today? I think about companies like ABL Space Systems and the really exciting emerging technologies that they're working on. How are companies positioned financially to benefit? And where is the investment coming from for these new technologies? Amanda, I don't know if you'd want to maybe kick it off, or Pete, you want to?
No, please let Amanda.
Sure, I can start off with that. So I think in terms of the launch industry and supporting telecommunications industry in general, what we're doing and focusing on from our perspective is really providing launch services and transportation to orbit. And these constellations, there's a variety of needs on their end in terms of how do you deploy a large constellation. There's a need for the larger launch vehicles, which can deploy quite a few of these spacecraft at the same time. But then there's also a need for technology demonstrations for very specific orbital placement and flexible launch timelines that are served very, very well by the smaller launch companies like ABL. And so that's kind of where we're fitting into the big picture and serving that market to be able to flexibly shift our schedules around to help serve the market, fill gaps in constellations where needed. And I think that's where a lot of the investor interest is coming from. So that's where our technology is really focused, is helping to serve our customers across the board in flexibility and turning things around on a quick timeline.
I'd like to throw a couple of stats out there. And no shade on Renard on this, but If you combine the market capitalization of Boeing and Airbus, you have about $200 billion almost. Right now it's between 180 and $200 billion in market cap valuation. In the last 10 years, we've seen incredible movement from these new companies that are raising capital from unexpected places. And just in the last 4 months and the last 6 months in particular, you've seen even more creative tools from direct listings to SPACs that have essentially created your new aerospace companies that are worth over $1 billion each, who I think there's about 13 in space between launch, satellite, and space tourism, of which, if you combine them all, they're bigger than that Boeing and Airbus duopoly itself. So it's just an incredible sign that more and more of these innovators and small businesses that have scaled in under 4 years to achieve that kind of market capitalization that is now providing more creative opportunities and solutions to the industry that haven't been thought about. And I want to point out that Peter and everyone else is making interesting references to Google Fiber, and people are forgetting about kind of the Verizons and the Dish Networks and the others that have been out there doing this kind of stuff for years. So why is it that we're thinking about how the tech companies are doing this, and why companies like ABL and many others continue to accelerate the growth of these capabilities for those Air Force customers and many others?
And to add on to that, Van, great points too. We've also seen, at least from the, I would say the demand side, the conversations that we're seeing in the industry originally started around what was that rural connectivity look, how do you get actual connectivity out to some very remote places? And then also I'd say conversely at the same time, like the smart cities, smart factories of the world. In the last, 12, 15 months, we've seen a rapid shift in the conversation to how does this actually empower the future of work as well? And things that were on the horizon maybe over the next 2 to 5 years are now all of a sudden being accelerated really rapidly as we are in this new norm, potential hybrid workforces, work from home scenarios. So we've seen some of that be rapidly accelerated, which I think and I hope is trickling into demand for the connectivity services writ large, and also that drive towards people recognizing that it likely isn't 5G versus satellite. It is what is your best use case in a way that closes the economic and business needs. And I think we're hopefully gravitating more towards that. And then that will drive greater demand for launch, for satellite services, and for things that are inherently produced, delivered, and sustained here in the Southern California area.
This is Renard. I'd just like to just add a little bit to that as well. The way that we've actually been working with, as a manufacturer, working with our customers is changed dramatically over the years. At first, it was we are going to receive a specification and deliver a said product. And now the engagement is more along the lines of what is the problem that you're trying to solve from the user's perspective as you architect the network, as you look at the various types of satellites and terrestrial infrastructure that's required, and the investments, the M&A discussions are all there. So as a manufacturer, we're utilizing a wide spectrum of tools across the business landscape as well, the technical landscape, and working side by side with customers because of the complexity of this problem is just so vast right now, and the opportunities are so great, as many of our other panelists, including Van, have mentioned in the past. Boeing, formerly Hughes, we actually brought the first satellite to the United States to close the transatlantic divide. Today, it's really about closing the digital divide. The equivalent, it's the same problem many years later, whether it's government funding through RDOF or it's economic development in other countries, serving the other 3 billion people, as we mentioned before. So there's been a very rapid evolution, and our companies are responding. Our customer is responding. Our customers are responding. So it's an exciting time.
Yeah, Van and Reynard, you bring a good point, and Van, you mentioned, the enterprise value of these newer players in the industry and how they are successfully raising private capital some even public capital by going public to support their technologies. And then you've got established players like Boeing, who has the opportunity for M&A in a more traditional sense, working with companies like Bank of America to help raise capital, forms of debt capital potentially. So, let's talk a little bit more about the specifics of capital raising and the financial benefit of doing so for these new players, being a standalone operation versus maybe partnering with more a strategic or established partner like Boeing.
Okay, I'll take a first stab at that. So look, venture in space, raising venture funding is an extreme high risk type of activity. So it's not normal to do that. And companies like SpaceX are almost 20 years old when you think about it, right? And so at the time when thanks to the tech tycoons that have kind of lowered the barriers to entry, thanks to others that are interested in increasing connectivity and 5G today, we now see on average 3,000 new companies per year around the world that are looking to optimize that kind of connectivity performance and solution. And if you are interested in going after a very aggressive, bold value proposition, then venture is the place for you. And normally that on venture funds, the math is about a 10-year return. But now what we're seeing are companies in under 4 to 5 years achieve this billion-dollar valuations, which is unprecedented. And Jeff used the word renaissance before, and it wasn't trying to be fun. Like, we are experiencing an incredible wave of what we call non-traditionals, or college graduates coming out of Cal State University, Dominguez Hills, coming out of Long Beach Community College, a lot of other places that want to be a part of these new companies. And when they ramp up and they scale aggressively, going through this kind of hypergrowth, they are looking to raise incredible capital, working with Michelle and many others, and continuing to capitalize on their new modes of production, augmenting the workforce, digitizing the production process. This isn't about seeing Oculus in factory floors or in production anymore. This is real. This is happening, and your champions like Boeing, Northrop, NASA, Air Force are using these new capabilities. And as we get smarter and smarter about opening up the training, the production, reframing the risk profile, we're creating incredible opportunities to raise more money, and not just from venture, but also from banks, from private equity, from high net worth individuals. There's a lot of interesting ways to do that, as well as accelerators. That's one thing Starburst is really focused on, is offering early stage companies those tools to grow and have access to that kind of capital that's out there, and it continues to increase.
Thank you. Yeah, it reminds me of the recent announcement Relativity made about a week ago on the exceptional, I think, Series D fundraising round. So it is incredible what is happening. At least Bank of America has been very active, partnering with space technology companies on SPAC transactions and taking pre-revenue, post-proceed companies public. So it's been a phenomenal shift for these newer players. Amanda, I'd like to hear a little bit from you on kind of, how other industry verticals are being impacted by the capabilities of the LEO space economy. The space industry has impacted industry verticals outside of telecom and consumers, such as healthcare and agriculture, energy. And the space economy is just emerging into new capabilities, such as infrastructure, space traffic, space debris, just to name a few. What categories have you experienced, given the customers that you work with, not just with AVL, but maybe over your career? And what do you think it means for the future of the space industry?
Sure, yeah. So my expertise is largely in launch services and infrastructure, so I can definitely kick off with that. I think from my perspective, some really interesting trends that I've observed over the years from working in the industry has been primarily the increased cadence of launches that are occurring and the development of new spaceports that are happening globally in support of the launch demand that's arisen. And so you're starting to see a lot more interest and investment going into global launch startups. And then also as a response to that, there's interest in having global spaceport infrastructure and access to space in other areas of the world that we didn't see before. So I think last year there was something around 114 launches from like 10 different countries, and this year is already on pace with that. Potentially even more launches coming, and additional spaceports are being built. ABL, for example, is helping build out a spaceport out in Shetland Islands over in the UK, which we're planning to launch from next year. So that's just an example of new spaceports that are coming online and pretty quickly as well. And we're seeing a lot of interest in that. There's also a lot of interest in responsive launch and deployment of infrastructure, not necessarily building dedicated infrastructure for launch, but having the ability to just launch from a concrete pad anywhere. And there's multiple companies working on that. ABL is one of them. There's others that are looking at this. It's offering a lot of flexibility of launch timing and orbital positioning. And that's how you can easily pair with this global infrastructure of new spaceports that are being developed. If you have a deployable infrastructure, you can just send that to where you need to be in the world and respond. So that's a couple of really interesting trends that I've seen. It's kind of the where you want, when you want launch philosophy, and it's starting to become a reality. With regard to things like space traffic and orbital debris, I do agree that this is something that needs attention. We try to be pretty mindful about that at ABL. For example, we're planning to deorbit our stage 2s, so we'll always factor in extra fuel so that we can actually relight our engine and deorbit and not keep stage 2s floating up in space for many years. And we're looking at how to do advanced orbital planning so that we can better project for our customers, as well as our own, if we go up to higher orbits, our own infrastructure that we put in space. Making sure that we're being good stewards of space. So that's something we're paying really close attention to. And I think it's getting more and more attention as we put constellations up. And I think we'll see it become more of an issue in the future as well.
Yeah, I'd love to hear more about the global partnership with the opportunities, in places like Europe and other parts of the world. What are the opportunities to expand and how is it possible to have those partnerships internationally? Who's interested and what is that first step or the next step to continue this international expansion?
Well, we did something that was pretty wild a few months back, where we helped U.S. government award any foreign startup to support allied space interests. So it was called our Allied Defense Accelerator for an international space pitch day. And companies we had an Indian startup doing space domain awareness, an Australian startup, and others that are increasing that kind of connectivity, that were awarded funds to support combined space operations that are first addressing military utility, but are really looking at that dual use to supporting commercial markets, and how are they leveraging sort of the defense needs to then go and offer those, to prove the technology out, and then bring those capabilities and solutions to the commercial marketplace. So we also did an event with NASA, but that includes working with foreign partners, allied partners, and today we're active in 10 countries, but we're tracking the world pretty closely. Startups in particular used to think about having a product market fit, but now think about having sort of a solution that's ready for government programs. As you see more and more government agencies, not just in the US, but with our international partners looking to on-ramp those capabilities, giving these early stage founders and companies that sort of international readiness and the ability to work across borders, which is a very exciting time right now. So it's definitely one to continue to watch, and helpful for companies that want to come to Southern California as well. Something else I want to point out is we were awarded a grant by Department of Commerce, Space Commerce, to work with UCLA to support the entire Southern California region. If you are a company that is overseas or is somewhere else in the US and wants to come to Southern California, at no cost to you. Just apply to the SCALE aerospace program, which is a collaboration between Starburst and UCLA. And I'm sorry for plugging that, but I'm sure one of my team will put that in the comments or Q&A if they want to tap into that.
Great, thank you. You know, I'm going to go ahead and take a couple more from the audience. So thanks for sending these along. So let's talk a little bit about LEO satellites and the affiliated debris that Amanda mentioned. You know, what is the timing of this issue? And Reynard, I see you grinning here. You know, companies like yours, and I know Aerospace Corporation has been very involved in this matter, have been for many years already addressing how they would, you know, get in front and find ways to be aware of the situation as these constellations grow from, you know, 8,000 or 800 satellites to 7,200 satellites, as Pete mentioned. Can you tell us a little bit more? I know some folks at LAADC, this was a subject we are very interested in and would love to hear more about.
I'll just say a few things. So the FCC is very active right now in actually developing and working with the industry, including aerospace and many other manufacturers, on what are those standards and what do we have to do to be great stewards for space. The opportunity that we have for growth is tremendous, but there's always the scenario of collisions that introduce a certain amount of debris that will ultimately exponentially multiply and block access. So what that is the key threat that we're looking at. We're constantly working with customers, we're working with SEC and including aerospace to develop those standards. It's a lot of a complex simulation and analysis to come up with these scenarios, but I will say that there's many of you have probably read in the news, there are different positions, whether you're a company operating at LEO versus MEO or GEO in terms of the positions that are being taken. But I think I have good confidence that we'll come to appreciate the reality that we all have to be stewards. And we're trying to really get that language of how do you actually propose regulations that not only domestically we can abide by, but also internationally that are achievable and don't put us at an economic disadvantage as well. So continued discussions there. That's still in work, a lot of complex variables and scenarios that we're evaluating, but it's definitely a very important topic that we'll continue to address.
Thank you.
I can add on a little as well. Just from my perspective, as a launch company, you never launch without prior approval and analysis that you've shown that you're not going to, you know, come within any certain distance of other spacecraft after you've deployed spacecraft. So there's a lot of modeling that goes into every single launch that we do that gets approved by the regulatory bodies ahead of time. And so we're always tracking, even day of launch, if there's any potential collisions that we could be at risk for, and we have the ability to be responsive to that as well. There's also the rise of some new startups that are doing some advanced tracking so they can track smaller and smaller objects in space, which is fantastic, and also really helping the industry as well.
Great. Always exciting. Always a new technology every day.
So just, yeah, and I think that question about debris, that's a really important question. And I'm an engineer, so if you hand that question to engineers, we would probably come up with a good solution. But it gets into, you know, I guess the human element. So you're relying on people to be good stewards is a challenge. And what I think a launch had to be modified recently because of the potential for a collision, and more stuff going out there. It's a good question because if something bad happens, it's not even local there. I think Reynard was mentioning the debris. Well, that debris is traveling at, I don't know, 10,000 miles an hour, and that debris can strike other things. So it really is important to protect that. It's, you know, we drive on roads, you know, we don't want to see trash cans, you know, while we're driving on Route 5, right, or 405. We can't have that because, you know, we need our cars to move. Well, the same thing out in space. So that's important. And to the extent that it's not done well, will harm the economics. Yeah, it's a good question.
Yeah. Yeah, and it really addresses the ESG importance in really everything we do as citizens, as companies, and trying to always do better and find ways to create new goals to achieve that. So kind of on the ESG topic and how we're addressing solving needs of our community and our industry, but also be getting in front of what that may address. I want to talk a little bit about workforce development. It was great to hear from Dr. Parham on some of the new programs that they've created in response to the growth in space technologies in Southern California with their systems engineering program. We'd love to hear a little bit more about maybe each of you and how you're addressing equal opportunity in your businesses, diversity, inclusion, and how you are making sure that, our STEM industry is being addressed and represented appropriately.
I'll go first. Deloitte does all sorts of things. There's about 58,000 or so on any given day of us in the United States. And I'll point out that when we decided to make a strategic investment in our ability to serve more of the space side of the aerospace and defense industry, and especially what people would think of the new space, we located in Manhattan Beach. It wouldn't be a pleasant walk in the heat today, but I could walk to each of the offices if we were all there for Ben, Amanda, Renard, and Peter. It was a deliberate decision to be located specifically there. We hire from all backgrounds, whether it be economics or systems engineering or sort of customer and analytics, and we feel that having that diversity of the talent pool is advantageous for how we can go and do stuff in the space industry writ large. So you'll see on public projects like the Vandenberg one that I mentioned earlier, or even our work on NASA's commercialization of low Earth orbit study a few years ago, the degree of the backgrounds and skill sets that we brought were varying wildly. It wasn't a bunch of engineers. It wasn't a bunch of economists. We brought the best, I think, of all worlds, that one. We also have, it's probably similar to every other company here, a lot of efforts around diversity, equity, and inclusion, and we make sure we apply those on a daily basis to our teams. So making sure that people have the opportunity to participate in the space industry, regardless if they actually, have a background in it. We can teach you some of the fundamentals, maybe not the true, nuanced engineering pieces of it, but we want to make sure we're providing continuous engagement for people that wouldn't normally be able to engage, or maybe previously hadn't been able to engage, to be able to do that. And that is making sure that we have the proper representation, of diversity across the board, from every single category you can think of the diversity through, gender, socioeconomic backgrounds, et cetera. And as the graphic says next to me, the all in, that's really what we're trying to do. We're trying to make it inclusive, and we're trying to bring that to the industry and our clients here in Southern California. And then I would be remiss by saying, we believe it's a great place to be recruiting from, with all the various universities, skill sets, programs, whether it's, Cal State, University of Domingo Hills, whether it's USC, whether it's UCLA. Like, this is an amazing pool of talent in the Southern California region. And we hope to be tapping it for years to come.
It is my mission to discomfort the status quo. I don't leave a room without spotlighting some of the antiquities that this industry is famous for. And I think diversity is definitely a key component of that. So I don't just believe in, even though our company is 45% female to male, I want to empower the way to empower disadvantaged and people that don't understand our sector is to help them understand the problem sets and the opportunities that exist in our sector. And I think what we're experiencing right now is an incredible opportunity for every community, and even something we're doing with NASA this year around working with HBCUs is going to be helping shine a light on where these problem statements are, where these solution challenges are, and not limiting it to the sort of oligopoly of industry that would normally go after solving it. And so it's my mission to communicate the industry's difficulties and problem sets to a community that would never normally hear about it, and give them the opportunity to come up and present those opportunities. And that is the platform and the stage we care very much about. So I welcome that.
I'll make a few comments, and my heart's beating pretty fast because there's quite a bit to talk about on this. But at the highest level, I think we start with, DE&I is it's the right thing to do. But then you can quickly get into hey, you solve the world's hardest problems, you need a diverse team of experts. Our leaders, including myself, just fashion ourselves upon being the integrator of those diverse teams of experts to go and solve those problems. But then you have to get into really standing behind that and executing on it. So, recently we've started to, at the Boeing Company, really publish more of our statistics. How are we doing? Because as anyone knows, to improve something, you've got to measure it first, and you've got to put the resources behind it. So, our outreach into the local community in terms of this working with schools through our university outreach programs, as well as making sure that when we're hiring, we're actually exercising that full spectrum, making sure that we get individuals that are not only the best for the position, but they're best for the organization as a whole. And you have to look at that organization in a macro sense to make sure that you're bringing things forward, that you're changing the status quo, that you're adapting, because you have to be diverse. You have to really bring everyone into the fold. The inclusion part is great. I think everyone's focused a lot in the past on diversity, but the inclusion, it's about what do we do when we get our individuals into the door? What is the culture that we set? And are we bringing people into the fold? So that's really where at the Boeing Company, where our focus is now, is trying to get to that I, and we're making great strides with that. The leadership team that I'm on, just great statistics in terms of exercising ethnic and male-female ratios across the board. We continue to drive that, but we do that because it's the right thing, but it also has a great business benefit. It's required to operate in a global company. So thanks for that question.
Yeah, and I'll tag on to that as well. Obviously a topic near and dear to my heart as well. And I totally agree that it's one thing to talk about promoting diversity within your company, and it's important to talk about it, but it's incredibly important to actually take action against that and have objectives and work against those and make sure that you're actually putting effort into increasing diversity and making sure people are heard within your company. I think, I was really fortunate. I actually worked for someone once who was formerly from Google, where they had a lot of attention on how to promote diversity and like little gotchas along the way of, just little things that you don't really think about in hiring that maybe people read your job description and they just immediately think they're not qualified. And, there's a lot of like lessons learned that can be applied. And I think one thing that we have at ABL that I'm super proud of is an HR department that's actually focused on that and thinks through it. I was in a program, a level meeting right before this call, and I think there was 3 women in the room that were presenting, and the company really like gives people the opportunity to stand up and be seen within the company and make sure that people feel heard. And so I think that's super important in any company. And then having people in leadership roles that can serve as role models for others. I think you kind of have to see it to believe it sometimes. I know for me, like I didn't even think I could work at NASA until I was in college. I had no idea that was a possibility for me. So like, I think sometimes you just have to really make sure that you're giving people the opportunity to shine, and then making sure that you promote those people within and paying attention to that.
Well, I mean, I can talk about this for another hour and 15 minutes. So I really appreciate each and every one of you. I love Van, let's change the status quo. I love, Reynard, your passion in doing the right thing, right? That's also part of ESG, right? We've been talking a lot about the environment, but the social part of ESG is so important. And really the business diversity, Jeff, that you brought to it, you don't have to be a rocket scientist to be a rocket scientist, maybe, but giving someone the chance. And Amanda, you highlighted some really good nuggets that I will definitely take with me. So thank you again, Van, Amanda, Jeff, Reynard, Pete. This is a great discussion. And I want to thank the LAEDC. I want to thank President Parham for allowing us to have this session today. And I'll go ahead and transition this off to you, Dr. Parham.
Thanks, Michelle. Wow. Looking at all the participants today, I know they have to be as excited as I am listening to all of you. And so I want to add my voice to the chorus of those that have said thank you, first of all, to you, Michelle, for stewarding us really through an excellent conversation. I want to thank Amanda and Jeff and Van for your thoughts and perspectives on this as well. And certainly Peter and Reynard for your keynote addresses. I think that have been important. I want to close, I think, also by inviting each of us to remember that workforce development requires being able to extend outside of the silos that lots of us are typically in, so that our aerospace companies and engineers are connecting authentically with our colleges and universities in the region in much the same way that Jeff talked about, to make sure that we are in fact being informed by you about what it is that you need from the students of tomorrow, and making sure that we are providing folk with access to that opportunity. And also want to close with a note about diversity, because each of our panelists, I think, mentioned the notion of diversity and implied in that analysis is a question about demographics. I would submit that diversity in my mind is more than mere demographics. And whether you have 5, 6, 8, 10, or 15% of this, that, or the other, be it race, ethnicity, gender, age, physical ability, or sexual orientation. For me, diversity is a question. And the question each of us on this panel and all of the folks participating today have to answer is that not does the demographics change, but rather do the policies and practices of our institutions or agencies change as a function of the changes in the demographics. So if we're X% women or X% Black or Latino or Asian or Indian or gay or lesbian or disabled or whatever, but we still act in traditional ways, then the only thing that changes is the facial makeup, but never the institutions themselves. So I would invite us to do that, because the future of aerospace and moving to close this digital divide is going to invite us to think like the Mae Jamisons of the world. And she reminds us when she speaks on science that it is important for scientists to be aware of what our discoveries mean socially and politically. And it's a noble goal that science should be apolitical, acultural, and asocial, but it can't be, because it's done by people who are all those things as well. So she invites all of us to, in fact, be political, to be cultural, and to be socially conscious in the way in which we do our work. And so on behalf of Bill Allen, I want to thank him, Shane Cullen, and the LAEDC. And again, thank all of you participants who have joined us today. And again, please join me in a thunderous virtual round of applause for this expert panel. This has just been fabulous. And Dominguez Hills and Bank of America, I know, are proud to be co-sponsors of this particular event. And we thank you and celebrate all of you for joining us today. Thank you.